Alright, so having looked at the similarity of length and working out scale factor k using image over original, so let's just review that. K equals the length of image over of original, and that gives you the scale factor for length. So scale factor k. So that allows you to switch between lengths of sides. For area, it works very much the same, but the scale factor has to be squared. So I'll show you what I mean. If we look at these shapes here, they're all similar shapes, they're all squares. If we go from this side to that side, so this is the original and this is the image. Okay, working out the scale factor there, I divide the length of the image, which is 2, divided by 1, and that gives me a scale factor of 2. But if we look at the area, what does the area do? It goes from 1 centimeter squared up to 4 centimeters squared. So it doesn't go up by 2, it goes up by 2 squared. So if that goes up by times by k equals 2, alright, the scale factor there, this one, k squared equals 4. So it goes up by the exact same scale factor that the length does, but you square it, and that's what gives you the new area. This works the same for if we do the next one. So if we look, I'm just going to use green color there. So this is my image again. Again, this is my original. So here, the k for the length, so to go from 1 to 3, k is equal to 3 over 1. Gives us 3. If we want to look at what the area does, it goes from 1 all the way up to 9. So quite a significant increase because we're timesing by k squared, which is timesing by 9. Alright, so that's how area works. Now, believe it or not, area and surface area do the exact same principle. So if you have a flat shape, you use k squared, but also in a minute we're going to do a cone as well, and it's the same process. For surface area. 2 regular hexagons are shown. The side length of the smaller hexagon is 2.4. Just get my highlighter there, which we can see. And the area of the smaller hexagon is 15 centimeters squared, so that's obviously the area within the shape. And the side length of the large hexagon is 7.2 there. Determine the length of the scale factor, the length scale factor, sorry. So to do this, we have to decide on the image and the original. So this is going to be our image, and the reason for that is because they're asking us later on to work out the area of this shape. So that's where our unknown is, and our original is the one there. So to get k for length, you do image over original, which is 7.2 over 2.4. Check the units are the same, centimetre is good, and that gives us 3 as the scale factor. Now, area is going to go up by 3 squared. So if we get 15 centimeters squared times by, I won't bother writing units, 15 times 3 squared will give us the area for the larger hexagon, which 3 squared is obviously 9, gives you 135 as the area for the large hexagon, and that's in centimeters squared.